How do you review a knife that hundreds, if not thousands, knife tubers already showed on their channel? By offering something that I personally haven't seen or heard on any of the channels and making it factual and free of hype and just sticking to the facts. So if you're ready for that, let's get into it. This is Shirogorov Quantum Ursus. The focus of my review will be on craftsmanship and materials, and for that we will be looking inside this knife, and I am going to also measure the blade's hardness using this Rockwell benchtop tester. But before we even start, I would like to tell the world how to pronounce the creator's name correctly. It's not Shirogorov and it's not Shirogorov, it's Shirogorov. The sha sounds like in the word shot. Shirogorov is not Gurov, it's Gorov. The G sounds like in the word good, and R is rolled like in a burrito. So Shirogorov. So let me tell you about this particular knife. As you can see, it's a Knife Center exclusive edition with a G10 tiger stripe inlays, titanium handle, and a Cromax PM steel. It also runs on multi-row bearing system. The original ones came out with a single row, but this particular model has a multi-row bearing. And they're the least expensive version they currently sell. I don't know if people just dislike the handle pattern or what, but they're selling these for $525, which is about $100 cheaper than just a regular production Ursus. Titanium handles, Cromax steel. Before I even get into disassembling the knife and testing it, I am going to talk about the steel, because this steel has been somewhat of an enigma, and there are some rumors and speculations about it that are easily debunked because there's nothing unusual or exotic about this steel. It's not a common steel, but there is nothing out of the ordinary about it, and I'll prove it to you first. Let's get into the steel. The only place where I found the composition of Cromax is the site called Z Knives. If you're a knife nerd like I am, you probably have seen that website. And it lists the composition. I'm going to read it right off my cheat sheet here. Cromax has 1.25% carbon. Stainless because it has 19% chromium, which is pretty darn high. It has 2.1% molybdenum, 0.8 vanadium, and 0.1 nitrogen, which is just a hair above the trace amount of nitrogen. Composition, as you can see, is a lot simpler than, say, MagnaCut. Fewer elements and very predictable properties. So first thing I did, I went to Lohmann website and tried to locate that steel. On that website, they list several of their products. You have to kind of scroll. It's mostly in German, but there are English titles where they show the products. So you can find that they have a table for their PM steels. And Cromax is not listed in it. But there is a steel they call QPM 4210 that has a composition that is very close to Cromax listed composition. So QPM 410 has 1.15% carbon, 19% chromium, just like Cromax, has 2.1% molybdenum, 0.6% vanadium, and only trace amounts of nitrogen. So very, very close. So my first thought was they've developed Cromax out of that steel by tweaking the carbon and molybdenum content and a little bit with vanadium. Maybe I'm right, maybe I'm wrong, but as I clicked on the link to the actual data sheet, at the very top it says comparable standards, and it lists ASP APZ10. Sorry about all this salad of numbers and letters. So I went online. I did what any inquisitive mind would do, and I wanted to see what other commercially available steels are made to that exact standard. Imagine my surprise. I'm not going to say pleasant or unpleasant. It was a surprise to find that Aerosteel, a new owner of Crucible, has a steel that they prosaically call, just like the spec says, APZ10, and check out its composition. 1.25 carbon, 19 chromium, 2.1 molybdenum, and 0.8 vanadium, and 0.1 nitrogen. So here it is, ladies and gentlemen. This is Cromax Aerosteel Edition. And I am super excited. Take a look at the heat treatment charts. It's different from other powdered steels in a very important way. It has a very high tempering temperature. It's reasonably high, but not extraordinarily high austenitizing temperature. And they say that black line on the chart on the top represents the wear resistance optimization for the steel. For corrosion resistance, that's the blue line, or you can balance it out, and that's the line in the middle. So if we were to assume that Mr. Shirogorov heat treats his steels to the maximum edge retention, he would go with the first line on this chart, which means he would austenitize it to 1125 centigrade. And as you can see, it is incredibly stable during tempering process. You can temper at 200 all the way up to 500 with almost no deviation in hardness. So if you do it at 200, you can achieve 61.5 Rockwell. If you take it up, which is unusual, usually the higher the tempering temperature, the lower is the end result hardness. But here, if you take it to 450 to 500 centigrade, you are going to get basically pushing 64 HRC. I'm excited about it for two reasons. First of all, it's a pretty straightforward path to success here. I am hopeful Sergey was able to maximize the edge retention for this particular model. Although blade being relatively long and thin, he might have chosen a midline of I'm going to venture to predict it's going to be probably between 61 and 62 HRC. We'll test it soon enough. What I'm also excited about, and you have no idea how excited I am, because recently I've proven, at least to myself, and some of my viewers would agree, that applying thermally applied coatings on the stainless steel blades is double idiotic, because you're really not adding value or stainlessness. And secondary side effect is you can actually over temper it, because once the blade gone through the complete heat treatment cycle and single or double temper, now you stick it, you coat it with Cerakote and stick it in the oven with 250 Fahrenheit, 150 to 200 centigrade to cure the ceramic coating, and all of a sudden your hardness drops by as much, I've measured, as 2 points. And to me, it's suboptimal and counterproductive. This steel can take any kind of coating. You can Cerakote the crap out of it, and you're going to still get above 61 HRC because it's tempering at 500. Now, obviously, Sergey doesn't Cerakote his blades. I have not seen a coated Shirogorov yet. By the way, did I mention what Shirogorov stands for? Shiro means wide, and Gorov means of the mountain. So wide mountain or monumental mountain, something like that. And Sergey in Russian often abbreviated to Sery. Friends call, if you have a friend named Sergey, most likely in conversations you'll call him Sery. It's like a nickname, which translates into the word gray. So it's like gray monumental mountain. That's what the name represents. And how well does it go with titanium and his typical finishes? Sorry, I digress. Before I take this knife apart, this is how I got it. It's a secondary market knife, though. I'm going to confirm what you already know. It's a very smooth running knife. There's almost no, what they call a double clutch. Is that what Metal Complex calls it? It's just barely perceptible and avoidable situation here, but there is just a tiny bit of that. And speaking of Metal Complex, here's the Kunvux caliber that he helped design. How smooth it runs on whichever bearing you use is evidence to how parallel the machine surfaces are. There are 4 surfaces involved, 2 inner surfaces on the handle and 2 outer surfaces on the blade itself. So if those 4 surfaces don't line up parallel, you're going to feel a little bit of less smoothness. I'm not even going to say grittiness, because by no means is this knife gritty. I carried it a lot, actually. It's holding up really well. Really like the style. Anyway, but here they are side by side. Now that I showed the action. Here they are. Shirogorov is just a hair longer in the blade and a little longer in the handle. And the action's smoothness is sort of detrimented a little bit on the Excalibur, because the parallelity is not set by just the handle. There is this cylindrical part in the pivot that compensates for the inability to fully separate the two halves. So by design, this part has clearances, so it's not going to be as parallel. You can't physically get it as parallel as the two slabs of titanium, although they did a fantastic job here. I'm not trying to bash it at all. Considering the technical difficulties they had to overcome, there's no less of manufacturing prowess here than in the Shiro here. See, I started using the westernization. So Shirogorov is not the only knife that gives you this smoothness. While we on the topic of Kunwu, this is their S-Tau. Oh, by the way, both Excalibur and S-Tau and all other Kunwu knives that I took apart run on a multi-row bearing system, so the smoothness is present there too. See that? Very nice and smooth. Very similar. In fact, Shiro, see how it caught just a little bit of that pinch point on the log bar. Out of the American knives, I think out of this size American knives, this Curtis is getting close to the Shirogorov action. In fact, near identical. I don't recall if it's multi-row, single-row bearing, but it's an extremely well machined knife. So now I'm going to pull the blade out, and all you need is a robust flat screwdriver bit for it. And I don't believe it's torqued very hard. It was not even torqued much, but because they machine these to very high tolerances, the screws, I mean the pivot hardware, the system actually doesn't get loose. So even if I loosen up the pivot screw, I don't get any play at all until I really undo it, where it's now actually the whole pivot is moving, and even then the blade is still developing, no rocking of any kind. And that means that the pivot screw or pivot hardware is thrust oriented, in other words, very tight tolerances between the pivot barrel and the hole in the blade. So right now the screw is completely out of the thread, and I still have zero play here. And I'm not disassembling the rest of the knife. I just don't think it's absolutely necessary for this video. Let me know in the comment if you really want to see a full disassembly. I will definitely consider doing it, and I'm just going to use like a punch to push the pivot out, and it slides out smoothly. There's no binding, and now I'm free to remove the blade. There's some lubrication. What does it say here? There's something. Oh, there's a serial number. Okay, that's good to know. I think some of the Russian laws actually require to serialize it, but something is going on there. Oh, I think I made a tactical mistake. The bearing balls are out of position now. They're all bunched in together. So I will have to take them out and reposition. So it looks like they actually make those bearings in the house, and there's some magnetism, and that's what's saving me right now from full embarrassment, because otherwise the balls would just roll out, all of them. So now I am actually forced to fully disassemble this knife, And for that, I just need another flat screwdriver. That was an unexpected turn of events. So, okay, it's not over torqued here too. So we can just, we'll just go like this. And now the spacer is sort of machined into the slots there. Should pop right out. Wow, look at the shape of that. So that's where the money is. Everything you see here, it's machined individually, and then these facets, somehow they need to make these facets, and if it's done on a lathe, it's probably a Swiss turn with the milling axes. Very sophisticated design. And now you can see what's happening here is interesting. These bearing bolts aren't detained inside the bearing race. They're just placed there. And I hope they're all still here. And so to reassemble, I have to position each little ball individually. That is so unusual. Okay, so let's try. This tip should be magnetic, and I should be able to use it to place the ball and try not to grab the next ball. And is there something interesting here? Take a close look. Where the balls are positioned, hope you can see it well. Where the balls are positioned, these are like slots and holes in this little disc. And that's to facilitate lubrication, I guess. Very unusual approach to designing a bearing. So instead of just buying a commercial mass-produced bearing somewhere, looks like they developed this one on their own. Let's test the blade for hardness. As always on my channel, I start hardness tests with verifying calibration of my Rockwell tester. For that, I use this serialized, independently certified, and rated 61.99 HRC calibration block made by Phase 2, which is a name brand in the world of hardness testing. The test itself is a little tedious, that's why I will accelerate the video, but you will see a one continuous, uninterrupted, unedited segment. And this way you will feel like you're here with me in my lab/studio working on this fun little project. Here we go. The test block is placed on the anvil, which is then raised upward toward the immobile diamond tip penetrator until it reaches minor force of 50 kilos, which creates a minor initial indentation on the surface of the tested item. All I had to do is zero the dial and release the major force of 150 kilos, which will put final indentation to measure 62.1 HRC. We're well within appropriate calibration. I am allowed a much larger arrow, so I am ready to test the blade. Here it is. I'm putting the bare side up, and I'm going to test near the tang or back of the blade, so it's not visible when the knife is reassembled. There is a very good, very long video of the tour of Shirogorov's factory where you can see that they are applying heat treat to very small batches. We are talking 8 to 10 blades in one time. And this one comes up at 61.9 HRC. Check the timestamp where I predicted the hardness. Very proud of myself here. Anyway, setting up for the second poke. In the video, you can see that they don't use atmospheric oven. Instead, they pack the blades into the stainless foil, and then, don't laugh, they add a piece of newspaper inside with the foil to burn out any oxygen. 61.6 HRC on the second poke. Everyone knows that paper burns at 410 Fahrenheit, and so when it reaches austenitizing temperature of 1950 to 2050 Fahrenheit, there's no oxygen left and no residue of paper. It all burns out, which prevents decarbonization of the steel itself, a common method amongst custom knife makers. 61.5 HRC on the final pokes. So this particular blade is heat treated to 61.5 to 62 HRC. Excellent. I am very excited that the hardness came out on the high end of what that steel is capable of, or I would say mid to high range, right? The reason is, and it's also the reason why I bought this knife so reasonably priced in the secondary market, is the person who carried it before me used it a lot, looks like, and the blade is pretty dull. So I'm not even afraid to do this. As you can see, apply some pressure and it won't cut through. Will it do the notebook paper? It gets in steel, but it tears more than cuts. Yeah. So I wouldn't call it particularly sharp right now. It will still probably sharpen a pencil, but it won't shave or split hairs. And that kind of drives me to the thought that this steel being heat treated to not its maximum edge retention could have used slightly different edge geometry. Now, it's hard enough to not worry about it, and it looks like it may have maybe 15, 16 degree angle per side. But I came up, I don't want to call it an invention, a new methodology on how to put a convex edge on a very thin geometry blade. So that's coming up on my channel. Please stay tuned, subscribe, and don't forget to hit notification bells because you don't want to miss that one.